I mean, my gut was off. This is why we have statistics. So you don't trust your gut. Depending on how hungry you are, sometimes your gut is wrong. All right. So you've got your data in L1. I do want to look at one thing before we begin. I do want to look at a quick, this is just my opinion, whenever you test an average, you should look at a histogram and a box plot of the data. So I'm going to throw that up on the screen real quick for L1. And I want you guys to tell me why you think I'm doing this. Whoops. Oh, I'm on the wrong kind of plot, that's right. Histogram, good. Modified box plot, good. Good. There's our data, where's my box plot? Okay, there's our data. Just do a quick zoom stat. Let's make this a little bigger. Why did I do this? Why did I make a box plot and a histogram of our data? Just to see real quick. What was that? What am I looking for? I'm looking for outliers. I'm looking at Chris back there. And I remember how you said I'm bringing the average down? Whenever I hear that, I start thinking of Gladwell and outliers. And I think, was Chris indeed an outlier? Or was the data set so noisy already that even though you were the low value, and you did, quote unquote, bring the average down because you're the low value, did it bring it down unnecessarily? Right? Is Chris an outlier? I don't think so. I don't see this marked as an outlier. It would be. The TI would mark it as an outlier for me and be like, hey, look at that. I also see what surprises the hell out of me. I see almost a bell curve. I wasn't expecting that. So that's why I like looking at the shape of data. We never looked at shapes of data last week, did we? I never had you guys graphing histograms last week. Why? There's a lot of very intense questions on a snow day. I apologize.
Is the sample size bigger?
That's one good answer. I like that answer a lot, actually. Sample sizes were definitely a lot larger. I wasn't that worried. But also, let me ask a better question. I'm asking kind of a two open-ended question. Aaron, what are you thinking right now?
Well, we didn't have so much data.
You didn't have measurements last week. There was nothing to scale.
It's just, yeah.
Everything was yes or no. Is it or is it not? So there's no box plot or histogram to make. It wasn't like a sliding scale from 0 to 1. You were either 0 or you were 1. Does that make sense? So there's no histogram to make. You only have histograms when you have continuous data that you can slap along on a histogram, or average, I shouldn't say continuous. When you have average values that you can slap onto where left to right actually is incrementally measured. So this is why I wanted to check to make sure. Now, remember your sector project, you were using that bootstrapping to create a scenario to deal with data that was horribly non-bell shaped and potentially riddled with outliers. This is really well-behaved data. I'm surprised. Pleasantly surprised, actually. So I feel pretty good about it. Let's forge forward. Nothing to talk about. So Chris, not outlierish at all. You're good to go, my friend.
Okay.
Good to go? Okay, here we go. Stat. Tests. Tests. There's your friend right there. T-test. Right near the top. I love this. If I had my way, I'd get in here and change all the damn names to something more logical, put them on the top, but I don't get my way. Not the school of Sean. T-test. All you got to do is tell it where your stuff is and tell it how to fill in this screen. So, first of all, is your input data or do you actually have statistics? We have data. We do have data, so you're going to leave that on data. Please, Sean, go ahead.
Mine would it be one sample, two sample, or regular?
Just t-test.
T-test regular?
T-test, just t-test itself, right? There shouldn't be a one-sam t-test. Just the fact that it's called, 89, that's right. So let me see it real quick. I'm sorry, I forgot I had an 89. Let me look. I could probably figure it out. Thank you, sir. Or can't see this right here. No, go back to one menu. Test. T. One, it's gonna be one sample.
Oh,
Yep, yep. Sorry, I forgot you had, my bad.
That's all right.
Yep, one sample.
Right.
No, you're good, you're good. What's gonna go here? 3. More confident. 3. Because that's the null we're testing against, right? We're testing to see if we deviate from 3. 3. Where's your data? Mine says list 1, that's where I put it. Is that good?
Yeah.
What should be in frequency?
1.
1. Yours might say that already. Mine doesn't, I have to change it to 1. Okay? And then down here we pick which sign is in our research hypothesis. I think we're going with less than, because we think we're underestimating. David, ask me that question. Oh, you're good, you're good. Okay, okay. Calculate or draw, your guys' pick. Do you like draw better? I like draw better. I noticed you guys defaulted to draw that. Let me do one thing first. I'm going to turn my graphs off. And then go ahead and draw away. Here it comes. It's going to take a little bit longer to draw. T-curves are notoriously more mathematical than Z-curves. Taking its sweet time. Oh! My type 2 error, completely unwarranted. Completely unwarranted. You guys getting some result? Yeah? What does that mean? Negative 4.3. Negative 4.3. Negative 4.3 what?
Standard deviation.
Yes, negative 4.3 standard deviation. You can't even see the p-value shaded, can you? That's because it's so far off the screen. The screen only shows you about 3 standard deviations. Negative 1, negative 2, negative 3. Negative 4 is down here off the screen. You don't even see it anymore. You're off the screen. Which means, if I may, oh, this might actually work. Hang on. Fancy. What just happened was, I'll just take mine away. Negative 1, negative 2, negative 3, negative 4.3. You guys landed here. That's where your average landed. Now, I don't even know what your sample average was. We were guessing it was around 2. We can run it on the TI to find out what it was. If you run calculate versus draw, it'll give you the average. I think one of the first things it gives you is the average. So my concern was that the margin of error was going to be so wide it would gobble up any difference. Well, apparently the margin of error wasn't so wide. In other words, you guys were consistently underestimating the 3. You were all guessing under 3, but you were guessing close to the same number under 3, which was kind of what the histogram was showing us too with the bell curve. Yeah, hopefully that made sense. So what you actually see is if you continued this curve out, which is actually continuing this curve out, that's your p-value right there. There's not much area there, is there? How much area? That. Is that less than 5%?
A little bit, yeah.
Yes! I was thinking more of hell yes, but yes, a little bit. It's less than 1%. It's 1 in 1,000. Just over. It's tiny. Do I believe that this is the curve you guys live on? Do I believe you live on this curve? What curve do I think you guys live on? I'm with you, Chris. I think you guys are down here. So which of these hypotheses do I believe? Yeah, I believe the research hypothesis. I believe we have a statistical answer to your guys' question. Do we underestimate 3 inches? The answer is, hell yeah. In other words, it appears. That's the statistical hell yeah. It appears you guys do underestimate 3 inches. So Rory, my type 2 error worry was completely unfounded. Because I overestimated the standard deviation of your guys' sample. Yeah. You guys were only off, well, hang on, as you were. You guys were only off on average by 0.7 inches. Oh, 0.7, that sounds familiar. You guys averaged 2.3 inches. That was your sample average, 2.3. It's only a 7/10 of an inch difference. The problem is, when you're only measuring 3 inches and you're off by 0.7, you've made 25% error. That's a big deal if you think about it that way, right? Percent error-wise, it's a large deal. So it comes out being very small p-value, with a pretty small standard deviation of 1/2 inch over 3 inches. I didn't mean to confuse anybody with this screen. I didn't mean to. I'll go to this screen. Ask me questions. I think we have the whole thing filled in. What kind of error could we make with this conclusion?
Type 1.
This is going to be a type 1, possibly, right? Because this is definitely a positive. As soon as Ben said we believe the research hypothesis, that opens up the chance of a type 1 error. We can no longer make it type 2. Because our conclusion is that we screwed up. Or our conclusion is that, well, yeah, I guess we screwed up measuring 3 inches. I guess that's a nasty way of saying it. But.
So what is the test statistic?
That's a great question. What is the test statistic, friends? The T score right here, Chris. It's kind of hard to see. Here. Right there, the negative, that's even worse. I'll just read it to you. I can't read it. Negative 4.3519. It's the number. That's Aaron, when you said standard deviations, I got so happy. That's what a test statistic is. Look back at the formula, the general formula. This is how you figure out on a standard normal or standard t-curve how many standard deviations you are from 0. You take your sample average minus your population average and divide by a standard deviation. That gives you distance from 0. So you are 4.3 units down from 0. That's significantly down from 0. You are no longer in the neighborhood anymore. That means the standard error is tiny. But the only reason the standard error is tiny is because you guys were so consistently underestimating. So even though in a sample size of 7 or 8 or whatever it is, even though it was such a tiny little sample size, you guys still were consistent in your 8 or 9 data points, which means the standard error is still pretty small. Pretty badass. Pretty badass, actually. Not expecting that. Is that good? Maybe. I'm happy about it. Oh, I look kind of cool. Any questions, please?
I can't read the p-value, I'm sorry.
Oh, p-value, 0.0012. Yes, sorry. Yeah, that resolution is kind of
I
crappy.
obviously have the wrong,
Hang on. That might be a little bit better.
mine didn't match, though.
Oh, maybe data's off a smidge.
Yeah. Mine
Don't worry about it, Chris. Don't worry about it. As long as, data entry is that's the last thing I'm going to worry about. Good. Fair? Good. Ask me questions. More questions. If you have them. Cool? Now that we got that one dialed in, you want to run through the 7-inch one and call it a day? Do the 7-inch one, turn that in for an in-class quiz, and just get the hell out of here a little bit early. That way you guys get in your cars, and if you have to take off, you get out here a little bit early because of the weather. Is that decent? Any questions about the 3-inch? We've moved to the 7. Sean, go, please.
My data points were up too. Outside, is that a divided line? Were you including?
No. I ran out of space.
Okay.
All 9 of these.
So on the 7-inch, I have to include the 4, the 3.
Yes, sir. These 3 are also there. I just ran out of space writing on the board. That's all.
Data points.
That might be it, potentially. So just make sure you get all those other 3 in there for the 7-inch one, Sean.
All right. Thank you.
No, good. And I'm so thankful that's the only thing that's get thrown us off is the data's not quite matching. That's the most minor of concerns. I'm glad we're squaring it away. It makes me happy we're squaring it away. But as long as the test itself is making sense to you guys, as long as the test itself is telling you guys and pointing to, okay, now I know what we're doing. I know what that number tells me to believe. That's really what I care about. There's a slider. Think of it as a carnival game. Going like this. Right? The slider's back and forth. And you walk up and there's the guy with the funny hat and the cane. And step right up! And then as you do the test, the hand begins to slow. And it begins to point to one and then the other. And as the data comes in, we actually had the discussion when I kept saying, oh, I'm afraid of a type 2. I'm afraid of a type 2. I started sliding this way, right? I'm afraid of a type 2, which means I was expecting a big p-value. So my gut is saying big p-value. But then Rory goes, yeah, but we underestimated. Maybe we're down here. And I'm like, yeah, but our sample size was so small. Right? Back and forth, back and forth, back and forth. And that's why that tells us which of these to stop our hand at. That is the final call for us to tell us which one we believe the most. Right? I mean, you could always get that result and say, you know what? I don't believe I'm going the other way. Don't do that. That's what politicians do. Right? Here's a bunch of data that says you should have this kind of a program. Thank you very much. I'm going to go ahead and go with my gut feeling. Why would you do that? Believe the data, right? Look at the data, believe it. It's good data. Right? Fair? I got data for the past 2 months. I was convinced our newest chicken, Agnes, was a rooster. Convinced. I heard crowing. At 5:30 in the morning, I'm in making my breakfast. On weekends, I'm from the area of the backyard. I'm like, shit. Here we go. You run the numbers. You guys know, the more birds I buy, the more likely it is I'm going to have a rooster somewhere in there. You know this. She's number 8. We've got 8 of them now. Well, we had 8. We're down to 4 because some of them died. But that doesn't matter. We still bought 8 chickens, right? Not a damn egg in sight. All my neighbors who bought new chickens are laying eggs since September. Can't find a friggin' egg anywhere. No eggs. Now the days are getting shorter, so it's going to get harder because they're going to stop laying now. And Agnes is a rooster. And a damn crow, and there's no eggs anywhere. Data. Agnes is a rooster. Agnes is a rooster. Agnes is a rooster. Got to change your name to Archie. And then Saturday I go out, walk into the coop to let them out. I look left, and I built this little duck house years ago because ducks come in every spring to our pond, and they poop, and they eat the duckweed, and they poop, and they eat the nice plants that I planted, and they poop, and they drive the pH up to 9.5, and my goldfish get like stoned. And I say, if you're gonna come in my pond and do all this stoning of my fish, the least you could freaking do, is give me babies. So I built them a house. I filled it with straw. I put scratch all around it to attract the ducks in. They come in, they eat my scratch, they poop on the bed, and they leave anyway. So I got this duck house. I leave it there just on the off chance. And I walk by, I look down, I'm like, I wonder. Pick the duck house up. 14 eggs in the duck house. Agnes has been laying in the duck house, which is the last place I thought to look. I looked under every freaking tree in the yard. Didn't check the duck house. So all of a sudden, Agnes is a rooster, Agnes is a rooster, Agnes is a rooster. Believe the data, Agnes is not a rooster. Agnes is a chicken, because she's got a bunch of data that pretty much shows you that she's still a chicken. You see what I'm saying? Believe the data. I posted a picture on Facebook, somebody commented, did you see her lay the eggs? Okay, you son of a bitch. No. Anyway, believe the data. The data tells you what to believe.